Hello, everybody. My name is Renchu Song. I am the engineering manager of the application and the developer tools team at TigerGraph. Welcome to my session about no-code, low-code graph visualization and analytics in TigerGraph. Let's take a quick look at the agenda today. First, I will talk about why we need no-code, low-code for graph. Then, I will skimming the TigerGraph no-code, low-code tools that are already available and some brand new tool in the development pipeline. Next, I will use these tools to do a demo. After that, I will conclude my talk and leave some time for Q&A. So why do we need no-code or low-code for graph? This all relates to the technology adoption curve. This is the famous framework illustrated by the Geoffrey Moore's his book, Crossing the Chasm. Every technology will go through different stages getting adopted by the market. There's no exception for graph technology. In the early stage, there are innovators and early adapters. They are the champions and do whatever they need to bring the brand new graph technology to the organizations. For those enthusiastic technical users, no-code, low-code is a nice to have, but not a must to move the business forward. However, this group of users only around 15% of the total market. There is a chasm between the early adapters and the majority market, which consists around 80% of the whole market. The majority of the market hesitate to adopt graph technology before they have seen proven value. No-code, low-code is the key for us to cross the chasm. It makes graph technology so easy to use, so fast to adopt, and so cheap to operate. And the graph visualization makes the deep insights of your data so intuitive to be consumed that it will win over the hearts of the majority of the market. So what no-code, low-code tools are available now in TigerGraph, and what tools do we expect in the near future? The first tool that is already widely used by our customers is GraphStudio. GraphStudio is a visual IDE for developers using TigerGraph. It covers the full development cycle of the backend business logic side of graph application. Start from designing a graph schema, followed by creating ETL, data mapping, and loading data in graph, all achieved with drag and drop visually. It provides a graph data explorer to let developers do ad hoc analytics and on the graph data. It also includes a GSQL IDE with syntax highlighting and autocomplete for developers to develop and debug graph queries. The second tool that is available and embedded inside GraphStudio is the Visual Query Builder. It's a super intuitive analytics tool for the users to drag and drop and mine the insights that you want to get from the data in what you see is in what you get fashion. It dramatically decreases the learning curve for graph analytics for everyone, including data scientists, data analysts, and business users. So this diagram depicts the underlying concept that's behind the Visual Query Builder. As a user, you start with asking a business question. Then you visually create a graph matching pattern that represents the question. Visual Query Builder automatically translates the graph pattern into a GSQL query, executes it, and visualizes the result to provide you deep insights. GraphStudio is loved by developers, and the Visual Query Builder makes it much easier for data scientists and analysts to compose business logic. But in order to prove the value of graph, make the deep insights consumable by the executives and the business users, it takes a lot of effort for our users to use BI connectors to pipe TigerGraph analytics result into other BI tools like Tableau. How can we simplify graph analytics and visualization so that we can dramatically reduce the time and effort required for such a process? Here comes Nala. It's a no-code visual graph analyzer. It bridges the gap between the consumers of graph insights and the users who need to build such experience with a much simplified graph visualization and analytics experience. It makes building graph dashboards on TigerGraph seamlessly and effortlessly. And the dashboards built with Nala can carry deep graph insights that can consumable by executives and business users. I'm showing you how now. So in this demo, I will show you how to use GraphStudio, Visual Query Builder, and Nala to build a simple financial and e-commerce fraud investigation dashboard without writing a single line of code. Let me start walking you through the dashboard. So the dashboard contains two pages, an overview page and an e-commerce fraud page. The overview page is composed of multiple dimensions and the types of potential financial and e-commerce fraud patterns that is detectable within the customer's data stored in TigerGraph. It serves as a starting point for the investigators on the consumer side to oversee all fraudulent behaviors stored in the system. And the e-commerce fraud page provides a 360 view for the investigator to check if some credit card is involved in one specific e-commerce fraud pattern. In the overview page, on the top, we are showing the money transfers with the transfer amount over a threshold. Here, the assumption is that money transfers over a particular amount could have a higher risk of being fraudulent. We use this table to show the sender's bank account and the receiver's bank account together with their transfer ID. We also show the transfer amount. We use this line chart to show for each time what is the total amount of money that is transferred. Here we use a minimal amount threshold to filter out the small transfers. Dragging the slider to change the threshold, and the table and the line chart will be updated based on the new threshold. Below the money transfer widget, we have this table to show the top 10 credit cards that are used for paying purchases of the most online accounts. Well, if a credit card is used to paying for too many different accounts, it could be more risky that this card might have been compromised. In this table, we show what are the card numbers, how many online account purchases the card has been used to paying for. And to the right of this table, we have this bar chart to show the top 10 IP addresses that the most number of purchases happened. The assumption is that if there are too many purchases happening on a specific IP, it might indicate that the device connected with this IP has been compromised and used for fraudulent purchases. A fraud investigator might need to take a look at this case by case. And at the bottom of this page, what we are displaying are purchases from a SIM credit card that have been made within 1 minute and from different states in the US. This could definitely be a red flag and could indicate that this credit card information is stolen. So here we have 3 fraud matches. Let's take a look at this particular credit card that ends in 0954. Click this investigate link. It brings us to the e-commerce fraud page for investigation. Here you can see the card number input field is automatically filled in with the correct card number we are investigating. So now let's take a look at this graph visualization widget. The card 0954 is involved in 3 purchases. The 3 purchases happened within 30 seconds at 12:32 p.m. on March 7th, 2020. 2 of them are from an IP in Alaska, while 1 is from an IP in Maine. This could be a pretty clear indication of potentially either the card is skimmed or the card information is stolen. At the right side of this page, we are showing the purchases paid by the same credit card after the fraud happened. Here we find 3 more purchases after the Alaska and the Maine purchase happened. We show the 3 purchases in a table, and we also visualize their happening time and their purchase price in the line chart. There is a chance that these purchases could also be fraud because we think that the credit card has already been compromised somehow. Now let me show you how I can build a dashboard like this. First, let's take a look at the schema of the graph that will power this dashboard in GraphStudio. I created this schema using design schema tool inside GraphStudio with drag and drop visually instead of writing GSQL DDL. We have detailed documentations, a bunch of YouTube videos, and many community blogs talking about how to create a schema and load data using GraphStudio. So I will skip this part today. So the center of this schema is people. People have multiple different data points around them, such as social security number, IDs, addresses where they live, credit cards, unsecured loans, phone numbers, and bank accounts. People can make money transfers between each other's bank accounts. There are e-commerce activities modeled in the lower part of the schema, centered around purchases. Purchases can be made from particular IP addresses located at different states. Purchases are made with particular online accounts paid by some credit cards and delivered to some addresses. All of these things together can be looked heuristically to start making decisions about whether or not something could be fraudulent. So let me go to the all applications page of NALA and create a new application. Now let me change the application name to fraud detection demo. And change the first page's name to overview. Okay, so in order to have the minimal threshold, I need to create an input widget. Click this Add Widget button to bring up widget config view. Change the widget type to inputs. Switch the chart type to inputs. And click the plus sign to create an input widget. Give it a name, minimum amount. Data type is a number. Widget type choose slider. Default value can be 40,000. Minimum value 20,000. And the maximum value 60,000. Save the widget and drag to resize the widget. Now let's create a table widget to show all money transfers larger than the minimum amount. Click this Add Widget button to bring up widget config view and change the widget name to be large money transfers. Switch the chart type to table. Here in the search bar, we provide you an easy and intuitive way to search graph matching patterns with schema-based auto-completion. Because we want to find the large money transfers together with their sender and the receiver accounts, we can start with sender bank account. Then search through send edge type to reach the money transfer. Then we want to add a filter to money transfers amount to be greater than or equal to the minimum amount we defined before. Then we add the bank account who receives the money. Okay, so now we change, we click this search button, it brings up the result. We change the config to include only the matched pattern and the money transfer amount in the table. Save the widget. Drag and drop to place the table at its desired position in the page and resize it. Now let's create a line chart to show for each time what is the total amount of money that is transferred. Because the underneath search is the same as the table, we just duplicate this table widget and edit it. Change the chart type to line chart. Change the category, which is the x-axis of the chart, to money transfer time. The value is money transferred amount, which is correct. Change the value aggregation to sum. Adjust the x-axis rotation and the name gap to make the ticks show clearly. Save the widget, drag to resize it. Now we have this large money transfers that is responsive to the minimum amount filter. If I drag it, you will see the queries got updated. Now let's create a table to show the top 10 credit cards that are used for paying purchases of the most online accounts. This use case requires advanced aggregations on graph pattern matching, so we can switch to Visual Query Builder on composing this business logic. In the Build Graph Patterns tab, go to this Find Credit Card Band to the Most Accounts pattern. It finds the top 10 cards that are used to pay for purchases from the most number of online accounts. Here we introduce an attachment concept, which is to attach a runtime calculated value to the matched vertex based on the matching results. In this case, we attach how many different accounts use this credit card to pay for purchases. Then we can order the credit card vertices by the account number attached to them from big to small, and pick the top 10. We can double click this vertex pattern to bring up this attribute panel on the right. Then you can add the filter, attachment, order, and limit properties on this vertex pattern. You might notice that the credit card vertex has an orange glow. This means that we will show them in the result. You can use this double tool to turn on or turn off each vertex or edge, which changes which pieces of the matched pattern to be visualized in the final result. Run this graph pattern, you will get the top 10 credit cards, and the account number is attached to each of the credit card vertices. Now let's go back to Nala and create a new widget. Change the widget name to top 10 most aligned accounts bound credit cards. In the search box, search for the visual pattern name. Find the credit cards bound to the most accounts. Run the search. Change the chart type to table. Here we can hide the applied time and the credit line attributes. Save the widget and resize the widget. Great. Now let's build a bar chart to show the top 10 IP addresses that the most number of purchases happened. So in the Visual Query Builder, go to this Find IP addresses of the most purchases pattern. This pattern is very similar to the previous visual pattern, except now we are attaching how many purchases happened at each IP address, and then we output this IP address vertices. So go back to Nala. Let's create a new widget and change the widget name to top 10 most purchases happened IP addresses. In the search box, search for the visual pattern name, find the IP addresses of the most purchases. Run the search and change the chart type to bar chart. The category is the IP address, which is correct. Change the value to purchase amount. Adjust the x-axis rotation and the name gap to make the tick show clearly. Save the widget and drag and resize the widget. Now let's add the last widget in the overview page, which displays the credit cards that are used to pay for purchases from different states in the US within 1 minute. In Visual Query Builder, go to Find Fraud Credit Cards pattern. This is a slightly sophisticated graph pattern. Here we match those credit cards that are used for paying two different purchases that are in different states. We have this state 1 not equal to state 2 filter. And then we also have these two limitations that the purchase time of these two purchases are within 60 seconds, which is 1 minute. Now let's go back to Nala and create a new widget. Change the widget name to fraud credit cards purchased in different states within 1 minute. In the search box, search the visual pattern name, find fraud credit cards. Run the search and change the chart type to table. Save the widget and resize the widget. Well done. We have finished building the overview page of the dashboard. Now let's continue to build the e-commerce fraud page for investigating the fraudulent credit cards discovered in the bottom widget of this overview page. Click this Add New Page button, open the new page, and name it e-commerce fraud. First, we need a card number input to specify which card we want to investigate. Click this Add Widget button to bring up the widget config view. Change the widget name to input. And change the widget type to inputs. Click the plus sign to create an input widget. Name it card number. Data type and the widget type stay unchanged. For default value, let's use one of the 3 fraudulent cards we found in the overview page, which is this number ending in 0954. Save the widget. Drag to resize the widget. Now we want to have a graph view of the purchases the fraudulent credit card involves in. This again is powered by a visual pattern. In Visual Query Builder, open this pattern named Find Fraud Credit Card with Detail. So this the difference between this pattern and the previous one is that first, we have a filter for this credit card number on the credit card vertex that equals to a string parameter. This is used to focusing on the specific credit card we are investigating in the e-commerce fraud page in the Nala dashboard. Second, we include the purchases, the IP addresses, and the states of the IPs, and all the connecting edges in the result. So the end user has a 360 graph view about the fraud. Now let's go back to Nala and create a new widget. Change the widget name to fraud detail. In the search box, search the visual pattern name, find fraud credit card with detail. Connect the card number parameter to the credit card card number input defined in this page. Run the search. We have this graph view. Save the widget and resize the widget. Perfect. Now let's find the purchases paid by the same credit card that happened after the fraud. This logic is powered by another visual pattern in Visual Query Builder. In the Visual Query Builder, open this Find the credit card succeeding purchases pattern. The upper left part of this visual pattern is the same as the previous one, except we don't output anything from the original fraud pattern. We instead find the purchases paid by the same credit card that happened after the fraud purchase. In the graph pattern, we are using the within widget to, it is a way to reuse some parts of the previous matched graph pattern for succeeding graph pattern matches. Here we are reusing the credit cards we identified as fraud in the previous step, and the previous identified suspicious purchases. In the bottom right part corner, we match the other purchases that are paid by the same credit card, and the purchase time is after the suspicious purchase. Now let's go back to Nala and create a new widget. Change the widget name to succeeding fraud purchases. In the search box, search for the visual pattern name, find fraud credit card succeeding purchases, and connect the card number parameter to the card number input defined in this page. Run the search and change the chart type to table. Deselect the purchase time and the purchase time epoch. Save the widget. Drag and resize the widget. Next, we want to view the succeeding purchases as a line chart. For specifying the trend, we just duplicate the table widget, edit it, add word trend to the widget name, change the chart type to line chart, change the category to purchase time. The value is purchase amount, which is correct. Adjust the x-axis and the name gap to make the text show clearly. Save the widget. Drag and resize it. Now we have all the widgets created. The last remaining part is to chain the two pages together. This can be achieved by editing this table widget and add investigate table action. For the time limitation, I will skip this part. Nala not only supports you to specify graphs, to specify the queries with visual graph matching patterns, it also provides you a fully fledged GSQL editor. If you are really a graph expert, you can develop arbitrary business logic with GSQL, then bind the query result to the rich set of visualization widgets seamlessly and easily. But we will skip this part as we focus today is the no-code, low-code graph visualization and analytics. So click the preview button at the top right corner, and you get the read-only view of the dashboard that can be shared with executives and business users to gain deep graph insights. Here concludes my demo. Hope you enjoyed it. What I showed you today is a preview version of Nala. We will make a beta release of Nala this summer. Stay tuned. So in summary, our team's mission is to democratize graph technology with the most user-friendly developer tools and graph-powered applications. What our team is doing here is to keep innovating and creating no-code, low-code tools for developers, data scientists, data analysts, executives, business users, and everyone that makes TigerGraph easier to use, faster to adopt, and cheaper to operate, both on-prem and in the cloud. Thank you. That is my talk, and I'm here to answer any questions that you might have.